Today we start with idioms, that are all those expressions that cannot be literally translated in other languages because they totally lose their meaning. Just a few examples. It's raining cats and dogs. It's a piece of cake. Out of the blue. And so on. All these expressions are very weird if we translate them in a different language. In Italian, for example, they don't make any sense. Like the Italian expression perdere smalto, that in English would be like to lose glaze. That has no meaning, but that in Italian means to be less effective, to lose pulling power or charisma, to lose something valuable. But speaking about glaze, even in ceramic production, during the glaze application by means of airless spray system, some of the glaze is lost, is wasted. So even in this case, something valuable, that is the raw material, is thrown away. And so today we are going to address exactly the glaze application systems. Not only the traditional one, but especially the new technologies that are recently taking place and that, in some cases, can change the setup of the production line. I am Davide Trentini, and this is Apparently Invisible, Chemistry in Ceramic. The ceramic glaze application, both before and after the digital printing process, takes usually place by means of analogical systems, that is, by spray airless systems. However, some new application machines have been recently appeared on the market, and these machines cannot be defined as completely digital, but they cannot even be comparable to traditional analog techniques. In some way, we could talk, in fact, of digital glazing by means of non-piezoelectric systems, even if the use of the word digital is probably incorrect. What does that mean? Without entering in a very complex field and without categorizing, we can just say that the new application machines are based on a different kind of injection and deposition of the glaze on the raw ceramic surface. And this is not totally digital, neither analogical. I want also to add that when we talk about digitalization, we are not referring, in this specific case to the application technology itself, but rather to the greater control and to the improved automation that these machines are able to provide. That said, these machines, even if they are still under implementation and under evaluation by ceramic tiles producers, they have been developed to reach, in the future, some important goals. Let's see. The first, and we have already partially explained, is about the possibility to decrease the supervision of the operator thanks to the greater automation of the machine. The second is about the possibility to reduce the amount of glaze thanks to its pinpoint application that do not need traditional suction system and the frequent and repeated washing of the spray cabin required by the airless application system. And finally, the third goal is the glaze application with three-dimensional reliefs. This is probably not immediate, but in the future, this new technology may support the creation of texture now currently made by the presses at the beginning of the production process. Okay, after this list, let's see now another important aspect. At present, there are on the market several known piezoelectric machines such as those we are talking about. Each of them is marked by its own features, but they all have a common denominator. What is this? They can work with the same kind of glazes that are used with airless application. With the glazes with the same particle size. Very similar, if not identical. This is very important because it allows ceramic producer to be very flexible in terms of purchasing and logistics, since they do not need to buy specific glaze to be used only with these machines. From a chemical point of view, this also means that each producer can work or act on the rheology of the glazes already in use, providing them with the proper parameters according to the different setup of the machine. In any case, we are implying that the glaze rheology must be carefully studied as usual to reach a good performance during the process. And regardless the specific features of a machine, they all can work in two different directions. Which one? They can be used for full field applications as well as for relief application. So let's now see these two scenarios in relation to the glaze rheology, and we start from the full field applications. In case of full field application, it is very important to reach a uniform leveling of the glaze on the ceramic support. And to make this happen, the glaze should have a low viscosity value. We could say that it should be slightly higher than a glaze usually used for spray applications. And at the same time, the glaze should be marked by a not too high flow limit. And I take this opportunity to remind you once again that the flow limit is the value of the minimum effort required to run a fluid. So, the low viscosity together with a flow limit that is not very high allow you to reduce or even avoid possible sedimentation phenomena or separation between the liquid and solid phases of the system that in turn may lead to localized sedimentation problems within the unit circuits of the application machine. At the same time, it is important to carefully check the surface tension of the glaze to reach a good homogeneity without compromising the cohesion of the glaze, of course. This is very important to provide the glaze with, we could say, a compact effect after application, a compactness both in the middle and on the edges of the tile. Of course, these are only general indications just to give you some parameters, because as you already know, all rheology values and so the features of the glaze must be regulated and adjusted according to the machine and the kind of application. This means, for example, that if we replace a glaze during the process or even we change its density value, we should proceed with a new rheological study to restore the balance that is very delicate between all the parameters. Let's now open a new chapter, speaking about the rheological values required in case of relief applications. To get a high level of printing resolution in this different scenario, the drop of the glaze must remain in its place where it has been discharged without collapsing and without expanding on the ceramic support. And to make this happen, the glaze should be marked by a high flow limit, and it should be able, at the same time, to rapidly restore its structure after its deposition on the raw ceramic surface. And this, I think, is quite clear and obvious. But what about thixotropy? That, I remind you, is a feature of pseudoplastic fluids to change their viscosity over time when subjected to a shear stress, moving, for example, from a pasty state, we could say almost solid, to a fluid state. So, what kind of thixotropic features the glaze should have? We can say that the thixotropic effect should be not very high, so that the fluid can keep its original features of viscosity and cohesion, preventing the drops to collapse on the ceramic body without compromising the definition of the application. To better and more easily explain also to non-professionals with thixotropy is that by chance is a very common feature of a great numbers of fluid. Let's make an example as usual from the cooking world. In this area, the most popular example of thixotropic fluid is, you can believe or not, the ketchup. The ketchup, when it's resting in the bottle, it appears as compact, thick, and almost solid. When shaken, instead, it loses, or even better, it changes its structure, becoming more fluid, able to easily get out of the bottle. Have you ever tried? Do it, because it's real. Joking aside, the topic of course is very complex and it would deserve deeper explanations, but this example, even if it's very simple, I think it's quite effective. At least I hope. Anyway, let's go on. Given that the glaze should not be marked by a high thixotropic behavior, the system's viscosity value, unlike full feed applications, shouldn't be too low, so that the drops of the glaze, that of course undergo to the stress of the application machine, do not lose their viscosity and therefore do not collapse on the ceramic surface. The glaze must not lose cohesion, and so the glaze drops must be bound one with the other. What does that mean? Even in this case, I try to keep things simple by using another example from the world of cooking. Suppose you throw on a desk, simultaneously and violently, a little amount of mayonnaise and honey. Mayonnaise, since it's not very viscous, will lose its cohesive force, splitting into several parts and leading to separate drops all over the surface. Honey, instead, thanks to its high viscosity, will be more compact, remaining still, exactly where it has been thrown, even if, of course, it slowly spreads over the time because of its low flow limit value. In short, all this to say that our glaze should be more like the honey, and so more viscous, in order to keep its compactness once it has been discharged by the nozzles of the application machine. And after this very interesting focus about the honey, even this episode has come to an end. I thank you as usual for being with us, and I remind you that all the episodes are available not only on the main platforms such as Spotify, Apple or Google Podcast, but also on our app, in which you can find other contents and that you can download for free on Apple Store or Google Play. You can find it by typing Z and S Ceramco, CERAMCO.IT, or apparently invisible. So please do not cry over spilt milk. You just need to wait, since I'll be back very soon. Take care.